Hello everyone, welcome to my video today on adding an infinite sum of square roots. I'm going to start off with this problem you see here. We're trying to find the value of the square root of 2 plus the square root of 2 plus the square root of 2, going on forever. They're all enclosed inside of the previous one. I saw this problem at a math competition and it intrigued me. Take a moment yourself and see if you can find the answer to this, and I'll get started on explaining the solution. So hopefully you've gone over this and seen if you can find it yourself. When we're looking at this problem, the first thing I thought of was, how can we turn an infinite sum back into some number that we can quantify? If we notice, x is equal to the infinite sum of the square roots of 2. So even if we started right here, went on forever, that's still the infinite sum of square roots of 2. So we can replace all of that with x. And so that's exactly what we're going to do in this next step. So we can rewrite it as x is equal to the square root of 2 plus x. Then solving for algebraically, x squared equals 2 plus x. So 0 equals x squared minus x minus 2. We can factor it into x minus 2 times x plus 1, giving x has roots -1 and 2. And because we're using the positive side of the equation, it'll be 2. We're using positive square roots. All right. And so the next question that I had, and this is where I started to go a little bit on my own and experiment, was what if we had numbers different than 2? Does it still add up to some integer number? Because I thought that was really interesting. And so I did the same thing. I replaced all of this with x, because it's just an infinite sum of square roots of k. And so x equals the square root of k plus x. We solve it algebraically, you get 0 equals x squared minus x minus k. And since k is another variable, we can't factor it like we did in the previous problem, and so we'll use the quadratic formula. So x is equal to 1/2 plus or minus the square root of 1 plus 4k over 2. So with that, you could plug in any value of k, and you'd get your value of x. So you can do that there, but I was wondering what values of k we could use that would yield an integer value for x. And so I just took this formula we have right here before we factored in and solved for x, and I solved for k. And k is equal to x times x minus 1. And so if we want x to be an integer, k will be an integer with the product of n times n minus 1, where n is an integer equal to x. So I started with any number times the number less than it. And so here we have k equals 2. That's the product of 1 times 2. And it'll give the x value of 2, because that's 2 times 2 minus 1. And we can do that again here with 6. 6 is the product of 2 and 3. So x will be 3. K is 12. That's the product of 3 and 4. And so x will be 4. Now there is one where it doesn't quite work, and that's k is equal to 0. So if we took k equals 0, that's the product of 0 and 1, and that would mean x is 1. But if we're looking at that, that would mean 1 is equal to the square root of 0 plus the square root of 0 forever. And obviously, that's not going to be 1, since we're just adding a bunch of zeros and square rooting. It's going to be equal to 0. And that brings us to the negative side of the equation. Earlier, we saw over here how we also got a negative root. And that is actually the answer to the negative square root each of these times. So if we said x is equal to the negative square root of 2 minus the square root of 2 minus the square root of 2, and so on, we can use the same k values. And using this expression, we can find the different x values. And those are the same ones that we had over there. That's the other side of the root that you can solve for. So here with k equals 2, that's the product of -2 and -1. And you take the -1 because that's our n value in the n times n minus 1 equation. So x will be -1 if k is 2 in this equation. So right here, the answer to this would be -1. And so on. So k is 6. That's the product of -3 and -2. X will be -2. K equals 12. That's the product of -4 and -3. X will be -3. And finally, k equals 0, that's the product of -1 and 0, and x will be 0, as it should be. And so if we did 0 is equal to the negative square root of 0 minus the square root of 0, and so on, then it'll be equal to 0, and that's the side that works. And the reason why this works, the x times x minus 1 being our value, is because since the infinite part over here is equal to x, then x, this negative x and the x here cancel because each of the values of k is x times x minus 1, leaving us with x squared, which just becomes x, which cancels with this. And I'll keep doing that forever until you're left with x squared, take the square root, and it's equal to x. So these two will be equal to each other. And that's why it works. And I'm going to leave you with one last problem. This is alternating, adding and subtracting. And just a hint for solving this one, see if you can get it into a format like over here with the quadratic formula. You might want to consider substituting this part right here with x, because that's just the square root of k minus the square root of k plus the square root of k, and so on.